Assalamu alaikum. Welcome back friends to the channel. Younes Charfaoui is here, and in this video we are going to learn about sealed classes for Kotlin for beginners. So let's get started. So sealed classes are a way to represent class hierarchy but in a restricted way. So let's say that we have a class called shape. Let's just make other copies of that. So another class will call circle. It will be like that. It will be the extent from shape, something like that, but shape isn't open, so we need to make it open like that. We can have also a rectangle. Now this is a hierarchy of inheritance, but it isn't restricted. What we can do to restrict this hierarchy is to add here in place of open, we add sealed. All right, now these are sealed classes. What does it mean? It means that at compile time, the compiler will know that no one can extend this class. This means that the direct subclasses of this shape class are known at compile time. So after the compile time, the compiler will guarantee that there is no other subclasses other than circle and rectangle to this shape class. Now you can use them like that. Here, for example, I can have something like R, which is double. And here in this case of rectangle, we can have X and Y. Now with this in mind, we can do something better. We can add these subclasses directly within this class here. So this is much better. Now, the main benefit for the sealed class is when to use it with the when. Let's say that I have val shape, okay, which is a shape. Well, first of all, you can't create a shape directly, as I said. Why? Because it is by default abstract and its constructor is by default private. Okay, so you can access this in it. Yeah, exactly. C type cannot be instantiated. That's the first thing. Let's try to create a circle. Okay, circle like that. We can access all the shapes directly from the circle, and let's put here 2.0. For example, now we can have the when expression on that shape. And because the subclasses are known at compile time, we can use something like that, add the remaining branches. So the remaining branches, this shape and rectangle, we don't have to add the else, okay? Because this shapes, the direct subclasses are known before. So in order, you can use this when in order to calculate the area, but this is not good because you can use polymorphism for that. For example, you can create one, for example, let's calculate the area. I forgot about the math to calculate the area. Let's just create, if it is a shape, then we can access something like that. If it is shape, we can do something like the following. Well, this needs to be a val. I forget about that. So they are members of this class. For the shape here, I can access the R, and the shape here, I can access the X and the Y. So this will return this one, I think. Okay, so this is how we can calculate the area. This is one thing. Now here, to calculate that, we need to multiply this by itself and multiply it also by the R. Okay, so we can call by P, math.p, something like that. This is how we can use the when. So the benefit of the when directly with the sealed classes is the restriction of the subclasses. But this is a worst example. I made it intentionally. So the best way to represent this area is not by using the when, because whenever we have to add another class, we have to come back to this when. This is the same as statement in Java. We have to come back to this when and add another branch, okay, which is not good. What we can do here, we can define an abstract function called area, right? And this will return something like double, like that. And we have to override this one here. We have to override it in the circle, and we have to override it here in the rectangle. So here we can just copy this one, exactly the same thing. I have to copy R, same thing here. I will have to do R multiplied by R multiplied by math.p. Okay, so this will work. Now the benefit of adding this is called polymorphism. All right, the benefit of adding something like that is that when you calculate the area right now, you have to do shape dot just area. And let's say we add a square. Let's say if you add a square here, the benefit is that we won't be changing that. I know we have shape circle here, okay, but I'm just showing the example because sometimes you don't know this. Sometimes let's say that this shape is coming from a function as parameter. Something you may say right now that this is similar to enums. Yes, sometimes, yeah, exactly. It seems like it's similar to enums because you can define several types, restricted types. Okay, we could do that with enums. We could even do area like that with enums. But the thing is, with this sealed classes, we can create multiple instances of this circle. But with enums, there is only one simple instance. Okay, you can't have multiple instances of circle. So this is the main difference between enums and sealed classes. Okay, so this is it for this video. Thanks a lot for watching to the end. Don't forget to subscribe to the channel and see you in the next video. Salam alaikum.